6.5, graphing inequalities. All right, I think this is one of the funnest things we do. I recommend that you get at least 2 different colored pencils, not super dark colored pencils, one lighter than the other, maybe like a yellow and a blue, you know, the colors that would interchange and make something else. But anyway, get some color pencils, or just make sure that you don't shade so dark that you can't see what you're doing. And you'll see what I'm talking about. But I've got color pencils, just come up there and get some. But anyway, we're going to graph inequalities. Now remember, inequalities are those things with less than, greater than, less than or equal to, greater than or equal to. We've worked with these before on a number line, but now we're going to put them on a coordinate plane and graph them. And you'll also be able to see them on your calculator. And the thing with inequalities, or anything that goes in your calculator, anything that you want to graph, always has to be in, that's right, slope-intercept form, which is the y equals mx plus b form. It has to be solved for y. Okay? Then we're going to identify the shaded regions, and we'll talk about what that means in just a minute. All right, so let's get started. All right, so we want, move this out of the way. To graph a line, the equation must be in slope-intercept form, or y equals mx plus b, or as we say a lot of times, solved for y. So you may want to write that on there. Solved for y. Okay? Solved for y. We will be graphing these inequalities, and they must be, like I said, solved for y. So what we want to do, this particular one that we've given in the first example, it says y minus 2x equals negative 4. Well, it's not solved for y because there's two things on that side, so we need to move something. I'm going to write it over here so you can see y minus 2x equals negative 4. We need to move this 2x. It happens to be negative, so we need to move it by adding. Okay? You see where we do a lot of the additive inverse, kind of like making a system of equations right here. This goes away. It's eliminated, and we have y is equal to, and I always told you, and you guys have been so good about it, put the x first. 2x minus 4. And now you know why I've had to do that, because then you can easily see your parts of your line. Okay, so if my equation is now solved for y, what is my m? Well, m is another word for your slope, your rate of change, the constant. What else have we learned about it? The constant. Whoops. Constant. The change in y over the change in x, right? That's all the same thing. That's what m is. Just remember, it's like nicknames for the same thing, okay? If you can remember, you know, someone's nickname, you can remember all their names. You know who we're talking about. All right, so in this case, if you have it written in the correct format that I've asked you to do, then you can easily see what m is. M is going to be 2. So write that there. And then B is the same thing as your y-intercept. Okay, y-intercept means where it crosses the y-axis. B and y-intercept are the same thing. And that is always going to be in the back end of your problem if you have it set up right. So this is going to be a negative 4. Alright, so remember we begin on B when we graph. Alright, so we're going to put a dot at negative 4 on your y line. 2, 3, 4, dot. Whoop. That's an awfully big dot. And then we're going to do, from there, we're going to do a slope of 2. Same thing as 2 over 1. So we're going to go up 2 and over 1. Up 2 and over 1. Up 2 and over 1. Remember, we use a little bit longer lines than we used to when we first started, but that's okay. Now, before you do anything else, we've just got our dots there. We've got to talk about inequality signs, okay? Inequality signs, this is less than. Remember, if it looks like an L, it's less than. And I want y'all to start saying the words as you're doing them, because I think that'll help you when you're doing other problems with inequalities. If you'll remember to say such and such less than or such and such greater than, I think it'll help you when you're doing your problems. So less than is this one. I think let's get a different color. I don't think that shows up very well. All right, and then this one has a line underneath it, so that's less than or equal to. Less than or equal to, and that makes a big difference. Okay, and then the next one says greater than. This one's greater than. And this one is then with the line underneath it, greater than or equal to. Okay? So you must know what those are and be able to say it out loud so that when we're working with this, you will be able to do this. All right, so back up here, we've got everything done. Now, this is an equality sign, so we can go ahead and graph this one, okay, just for practice so we know what we're doing. We did our slope and we just draw our line. Now, with the inequalities, though, that's going to be a different sign right there. That's totally different. We will not be just automatically drawing the line. So you'll put your dots and then look and see what your inequality sign is and then go from there. But if it's an equal sign, you can do it as before. Draw your line and that's done. Okay, but watch what happens when we're doing the inequalities. Okay, let's go to the next slide. All right, so when we're graphing inequalities, there are certain rules. All right, when an inequality is a less than or greater than without the line underneath it, the boundary is a dotted line, like this one right here. Okay, so it will not be solid. So it makes a big difference. It will be wrong because what that means is it does not include the points on that line. It includes points maybe above or below, but none of them on that line are going to be any of your solutions. Okay? Points located on dotted lines, again, are not part of the solution. So if it does not have a line underneath it, it's dotted. Okay? And then when an inequality is less than or equal to or greater than or equal to, the boundary is a solid line, just like we've been doing before. That means that the solutions, the ordered pairs that are on this line are part of the solution. Okay? Now, if it is a greater than or equal to sign, then we're going to shade our graph. It's going to be shaded above the line. Okay, all points above that are greater than. And if it's a less than or equal to, we're going to shade below. Okay? All right, so let's practice on these and you'll see what I'm talking about. All right, so the first one says, and you just read it, it says y is less than negative 2x minus 1. Now, just as before, if it's not solved for y, or, you're going to have to do that first. And then you have to remember the rules of those inequalities that we did before. But like this one is solved, let's just go ahead and start on this one. I'm going to change my color. All right, so I begin with my b. Well, my b is negative 1. Whoa, put your dot right there. And then the slope is negative 2. Remember, that's like over 1. So I'm going to go down, because it's negative, down 2 and always write 1. Until you see which way the line's going to go, always go to the right first. Then once you know which way it's going to go, then you can go backwards. Okay? All right. So there's my dots. I know that they're all in a line. That means I did it right. As long as I followed the signs of these things, right? I know it's drawn right. But this says less than. All right, so looking up at my rules up there, a less than without a line underneath it means it is a dotted line. So I'm going to change my color so you can see. I'm going to make this a dotted line. Now, I'm going to start and I'm going to dot in between, kind of like that. So you see it's not a solid line. Okay? And then we have to shade it. So less than means all the all the points in the region below that line. Okay, below the line, any of these points would work and solve this inequality because this is a less than. So that means any of these points are less than that line. So we can go over here. And I'm going to get highlighter. And I'm going to shade all, whoa, not that big. Hold on. Must have had that for something else we were doing. And shade all my line below like this. Now you don't have to color it in completely as long as I know where your shading is. And this is why I say color pencils are probably good. And you want to make sure you've got that line graphed correctly first before you shade because sometimes it's hard to erase all that stuff. Okay? Alright, so it's shaded below, so that means any of these points, and you can check them. And why don't we do that? Let's take one point. Let's say right, let's change this to my pen. Let's check this point right here. That point location is 1, 2, 3, -3, 0. Okay, so let's put that in. Remember, this is your x, and this is your y. If I say that, then I'm going to say 0 less than, because 0 is my y, -2 times -3 minus 1. See if this is true. So -2 times a -3 is +6. 6 minus 1 is 5. So this is saying 0 less than 5. Is 0 less than 5? Yes. So that means it is true. But if you picked a point over here, say you picked 0, 0. If I put a 0 there and I put a 0 there, is 0 less than -1? No. So you can check, you can test yours to see if you've drawn it in right, if you really want to. You can test the points and see if it's true or false. If it's true, it's in the shaded region. If it's false, it would be in the non-shaded region. Okay? All right, let's do the next one. This one says y is greater than or equal to 2x minus 4. Again, we're going to start with our b. In this case, it's -4, so I'm going to start it, put a dot. 1, 2, 3, 4. Right there. And then I'm going to do a slope of 2, which is positive, so that means I go up 2, 1, 2, and always right for the first one. Now you see which way it's going to go, so you can continue doing it if you need to do it in the opposite direction. We don't have to in this case. But remember, it's super important to always go up or down, and then always right for the very first dot. And then after that, you can see which way it needs to go. Okay, now this one says greater than or equal to, so that means it is going to be a solid line, which means that the answers on the line are also part of the solution. As you could test it over here, if you pick this point right here at -1, 0, -1, it would not work, okay, on this particular equation. But this one, the points on the line do work. And we'll try it over here. We'll do some over there. But in the meantime, it says greater than or equal to, so that means we now have to shade. We've got the line written right, and now we have to shade. Let's go back and shade. And that says above, okay? So that means it has to be the points above. Any of the points above, okay? And you can check your answers if you want to. If I plugged in 0, 0, which is the origin, it's in the shaded region, it should be a true statement. So if I say 0 greater than or equal to, I'll put a 0 there, that makes that 0. Is 0 greater than or equal to -4? Yes. So you can check your answers. You can check your points on the line if you want to also. Alright, so over here it says y is greater than -2. Alright, so I'm going to switch colors. Alright, so y is greater than -2. Alright, so that means I have a y and a -2, so I know I have to put a dot on -2 on my y. And we've talked and discussed this a million times. A y something, it's going to be a horizontal line. If it doesn't have any x involved, it's a horizontal line. So I could pick any points on this horizontal line. Okay? Any points at all. Now the reason why I did that, I don't want you to just automatically draw that line because the symbol says greater than. So that means it is a dotted line. That means all the answers on this line are not included. Okay? Now this one says greater than, so that means above. So notice how when you have a horizontal line, how it goes above. Let's change it to, well, we'll just keep yellow. No, maybe this one. Okay, above, greater than -2. That means all numbers bigger than -2 will work. So let's see. 0 go in there. If I put 0 in, is 0 greater than -2? Yes. How about -2? Is negative, that's the point right here. I want you to check that. Is -2 greater than -2? No. Okay, they are the same. They're not, one's not greater than the other. So that's why it doesn't work. Okay, so like I said, you can check your points and test it to see if it's true. And you want to check that and get used to doing it on your own so that way you'll know whether you're doing it right, especially when you're doing homework. All right, the next one says x less than or equal to 2. All right, so it says x is 2. So we put a dot on x is 2. And we've learned that that is going to be a vertical line, so we're going to have points vertical, okay, because that's an undefined slope. This says less than or equal to, so that means it's a solid line. Okay, solid line. And it says less than 2, so that means the number's less than 2. All right, so if you think about it, which way would that shade? On a number line, if this is your x and this is your number line and all the numbers less than 2, that means it's going to go this way. So when you have a x is something line, a vertical line, it's going to go left or right. But just think of the numbers on the number line. Which numbers are less than 2? That's the ones over here. Okay? All right, so if you wanted to check it, you can go back and say, okay, this point over here is 4. Is 4 less than or equal to 2? No. But is 0 less than or equal to 2? Yes. So you can check points on both sides to see if it's true or false, and then you know you shaded it correctly. Okay? All right, so you have to remember your rules for solving inequalities because they still apply, and they're not all going to be solved for y for u, so you have to do that first. So remember, the main rule with inequalities is if you divide or multiply by a negative number, you must flip your inequality sign. So for example, they gave us 9x, whoops, where'd my pen go? They gave us 9x minus 3y is greater than 6. I need to solve for y. So I moved the 9x over, I subtracted it from both sides, and that's why it's over here. Now it's negative. Okay, and I always put my x in front, so it's always set up for you. Okay, then I'm going to divide by a -3. Everything's got to be divided by -3. So when I get this, I'm going to have y, but because I was dividing by a negative number, I must flip my inequality. So notice how it turned around, 3x minus 2 when you simplify this side. So make sure you do that because if not, when you test points, it will not be true. All right, so I'm going to start at -2, which is my b, and put a dot. My slope is 3 over 1, so I'm always going to go up or down first. This is positive, so I'm going up, 1, 2, 3, and always right. And then after that, if you need to go the opposite direction, you know which way to go. Okay, and then I'm going to go down and left. Okay, then I'll look and see, okay, it's less than, but not less than or equal to, so it means it's dotted. So I'm going to have a dotted line. All right. And then I'm going to look at the shading. This says less than. Okay, so less than means it's going to be shaded below. So I'm going to shade mine below. And then if you need to check your points, you can check points. All right. The next one says x is less than 3. You'll notice it has an x, no y, so it's a dot on the x at 3. And this is going to be a vertical line, so you can put a dot anywhere else you want to on that vertical line. It says less than, so it's going to be a broken dotted line. And it says shaded less than, so that means all numbers less than x is 3, so that would be this side. Okay? All right, now let's go back. Let me show you something with the calculator. Ready to go. All right. Took a while to get that thing set up, didn't it? All right, so on your calculator, we're going to go to y equals, and we're going to use this right here. All right, so this is 3x minus 2. Go ahead and type that part in. Now, when you want to graph, all these are set up to be equal signs. Okay, so we can change that very easily because we have this apps button. And go ahead and push the apps button. Oh, I forgot, mine does not have it on my computer. Okay, well, we'll do it a different way. Go back over here. I can go over here and do it too. This little toggle that's flipping up and down right here, this little cursor thing, you can toggle it so that it will work. So I'm going to push enter and enter. That's greater than. When it's all shaded above, that's greater than. And if you hit it one more time, that's less than. So if we want to do it this way, we can do it with this symbol right here. Just toggle it over and it'll go ahead and graph. And it will shade it for you too. So you can check your answers to make sure you shade it in the right way. The only thing that this one will not do, using that particular way, is it will not show broken or solid lines. In class, I will show you the apps situation because this calculator on my computer won't do that. But the apps button will show you the broken and solid lines. So in class, I'll have to show you that. But for now, just know that you can do it by going to y equals and toggling this either to be above for shaded for greater than or below for less than, and it won't do the dotted or solid line thing. It's all going to be solid, so but it will shade it for you. Okay, so just know that. Now notice it's got an x less than 3 here. It won't do that for you with the way it's set up right here. Okay, so you're going to have to do those. And just check your answers by yourself. But I will show you more tricks with the calculator when we're getting class because this one is very limited. I can't add on any applications to this program, so I will do that and show you the ones on your calculators in class. But we will work on this more and practice this, but again, color pencils are really cool, especially when we do the next section. So come see me if you have any questions. And I'll see you in class.